Hi guys, this is question number 3 in your Collision 2 homework paper. You're going to have two objects, two carts, one of them 0.3 kilograms, the other is 0.1 kilogram. One goes to the right with 2 meters per second, the other goes to the left with 3 meters per second. And after they collide, 0.1 kilogram object goes back with 1.2 meters per second, and 0.3 we do not know which direction it goes and what's the velocity of that. And in part A, they are simply asking for the velocity of the first object. And simply it's m1 v1 plus m2 v2. These are initials, and that must be equal to m1 v1 plus m2 v2. And these are finals. So since there's no stick in, nothing else, we just use regular conservation of momentum, and we'll just plug in the numbers right now. So 0.3 times 2 plus 0.1 times negative 3, because it's going to the left, and remember momentum is a vector quantity, and 0.3 times unknown velocity, so we can just put v, plus m2 0.1 times 1.2. So since it's going to the right, it's going to be positive. So once you do the math, 0.6 minus 0.3 equals 0.3v plus 0.12. Subtract, so that is going to give us 0.3, subtract 0.12, so 0.30, 0.12, 0.18 equals 0.3v. Then once you divide both sides by 0.3, you're going to find your velocity as 0.6 meters per second. So after they collide, this object is going to have a velocity of 0.6. So that means this guy is going to move to the right with the velocity of 0.6. And the question is asking in part B, is it an elastic collision or inelastic collision? So remember, the rule for elastic collision, both momentum is kinetic energy is conserved. So what should we do to be able to figure that out? We should simply measure the initial kinetic energy of the system and the final kinetic energy of the system. Then basically K1 plus K2, K1 plus K2. Then we will just compare those two kinetic energies. If they are equal to one another, then we can say that it's an elastic collision. If it's not, then it's inelastic collision. So I'm not going to write down the equations for kinetic energy individually. I'll just go with the numbers. So 1/2 m, which is 0.3, times velocity square, so 2 square, plus 1/2 m for the second object, 0.1 times. Alright, so here velocity is, you can say it's -3, but you have to be careful. This -3 is supposed to be within the parentheses, because you're taking the square of -3, which means you multiply -3 with itself. So as a result, you are going to have a positive number over here. So kinetic energy will never be negative, it's always going to be positive. So once you multiply all of those, you are going to find your kinetic energy as 1.05 joules. And once you calculate your kinetic energy afterwards, same thing, 0.3, but this time velocities are changing. So this guy is going with 0.6 this time, 1/2, 0.1, and this guy is going with 1.2 square. So you can definitely see that both of the velocities are dropping. So that means your final kinetic energy will be obviously less, but if you do the mathematical calculation, you will also see that they are going to be different. And your final kinetic energy is less, so that shows you that it is inelastic collision, because kinetic energy is not conserved. So what's happening basically, this guy is hitting to a spring and then it compresses this spring. Alright, and it continues to speed, so it's 1.2 meters per second. So we don't have this object anymore, so that's what's happening. So there was a spring, and then it's just was going with 1.2 meters per second, and it is compressing that spring. And question is, calculate the potential energy of the spring when it reaches maximum compression. So maximum compression means this guy is going to transfer all of its kinetic energy to this spring. So that means all of that kinetic energy will be converted to potential energy of that spring. Then you can just say kinetic energy must be equal to spring potential energy. So you do not need equation of this because they are directly asking for the potential energy on the spring. So they are asking for US directly. So all we need to do is find out initial kinetic energy. So that is going to be 1/2 times mv squared equals US, and 1/2, my mass is going to be 0.1, and then my velocity was 1.2 meters per second, and then that's US. And once you do all the calculation, you will find that your US is 0.072 joules. And in part D, which color should we use? Green. In part D, they are simply asking for maximum compression of the spring is 0.1 meters. Calculate the spring constant. So they give you the maximum compression, which is X, as 0.1 meters, and they're asking for K. So that's also a straightforward question, because we already know US, and US equation is 1/2 K X squared. X is given, we know our potential energy, then we will just solve this for K. And once we plug in all of the numbers, 7.2 1/2 K 0.1 square. Then to be able to solve this, what should we do? First, we need to multiply everything with 2. So to get rid of this 1/2, so 2 times 0.072 equals K. 0.1 squared is basically 0.01. Then you divide everything by 0.01, and once you divide this everything by 0.01, you are going to be able to get your K. So 2 times 0.072 divided by 0.01, that is basically what you're going to put on your calculator. And once you put everything in the calculator, you'll find your K as 14.4 newtons per meters. Alright, so that is the K of the spring. In part E, they are asking a little bit different question, and we didn't have enough time to solve enough questions about that, but I'll explain that over here. So your force is not constant, so you are going to have a function for your force. It's not squared x cubed. So they are saying that this is how your force changes on the spring. And if you think about it, your potential energy, or if you check your notes, I believe I have given that equation. If I haven't, then I apologize, but this is going to be the equation in between energy on a spring and a force. So energy on a spring is negative F times dx. So integral of your force function with respect to distance. And you're going to have that negative sign because of direction convention. So then since this is going to be the equation, all we have to do is plug in force into that function and then solve that integral. And then once we do this, u equals negative, f is also negative b x cubed dx. So we are not trying to figure out position or like any position at any time. We are trying to figure out energy function. So we don't need to have boundaries for that. We will just get the integral of that. And then that is going to be our solution for u. Then u will become negative, negative, and b, they all come out. So negative times negative is positive. B also comes out, so that's b. Then we are going to have x cubed dx inside. So how are we going to get the integral of that x cubed? You should remember that increase the power by 1, x plus 1, and divide it by the new power, x plus 1, 3 plus 1. Then my u as a function of position is b times x to the 4th divided by 4. This is b, not 6. Alright, so this is my function. And what condition did they give me? When x equals 0.1 meters, what should your b, or calculate your b value for x equals 1.1 meters. So what should we do? We should substitute this x with 0.1, and then we know my potential at 0.1 meters. My potential at 0.1 meter is 0.072. Then I will just solve the equation for b. Then 0.072 equals b times 0.1 4th divided by 4. So once you do the calculations again, you cross multiply first. So 0.072 times 4 equals b times 0.1 to the power 4. So if you divide both sides with 0.1 to the power 4, then you will find your b as 2,880. Unit for b over here, so if you consider from here, it's b. If you take b out, it's force divided by x cubed. Then unit for force is in Newton, and unit for distance is meters, so meter cubed. So the unit for b is going to be newtons per meter cubed. And this is your solution for number 3 on your collision 2 homework.